Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So let's continue with the second part of chapter 7. Okay, it's about addressing mode. Addressing mode refers to the methods a CPU uses to specify an operand in assembly language. There are 5 addressing modes in MIPS: register addressing, immediate addressing, base addressing, PC relative addressing, and pseudo direct addressing. For this part, I will explain the 3 addressing, and then the second one, the fourth and the fifth one will be explained together with branch and loop. Register addressing mode uses registers for both source and destination operand. All R-type instructions use register addressing mode. These instructions are executed more rapidly compared to other addressing modes as they do not require access to memory. We can consider that using the register addressing is the fastest among other type of addressing mode. Okay. For example, register addressing. Example 3, use sample of command add dollars $0, $T1, and then $T2. So means that the content inside T1 and T2 will be added together and then stored inside the register destination, which is the S0. So here we can decompose the command into machine instructions as add is a R type, which means op is 0 and then function is 32. And then because this is a register addressing mode, so the first source is RS T1, second source is RT, which is the T2. Okay, the value is in a register ID, and then after that with the register destination. Okay, so as shown above, the value of RS, RT, and RD should be the actual register number. Another addressing is what we call as immediate addressing that utilizes a 16-bit immediate value along with registers as operands. Certain I-type instructions, including the ADDI and load upper immediate instructions, utilize this form of addressing. Similar to register addressing, the execution of instructions happen faster because it removes the need for memory access. So as long as you did not, as the instruction was not involved with the memory, the execution will be faster. For example, ADDI T0 S3 and then -20, where the source is the S3 and immediate -20, okay, and then the destination is the RT. Thus, T0 is equivalent to S3 plus -20. In here, the immediate is not stored inside the data segment. In fact, it's automatically was assigned as a constant or immediate in the command. Base or displacement addressing. So I have explained in chapter 7.1 about the load instruction and store instruction, right? So the base or displacement addressing is used for memory access instructions like load word and store word or load or store instruction. The content or the component inside of this base addressing is that in require base address that will be stored inside the base register, in this case RS, and then offset which is the 16-bit immediate value uh, with a sign extended, means that it can be negative and it can be positive number. For base addressing or displacement addressing, to calculate the effective address, it will require the base address that's stored inside the RS plus with the sign extended offset. How does it work? The base register would point to a starting location in a memory. So the RS will contain the data memory location. Okay, so the content inside the RS, okay, will be added together with the sign extended of the offset. Okay, so the offset will be assigned to 32 bits and then added together with the content inside the RS. Then you will get the targeted or the effective address. Okay, then it will specify the effective address to the pointed memory. Okay, why does the offset is needed? It's because of the base register will only contain or store the starting location in the memory. Okay, so in the case of similar or the actual the usual way that they assign it is that they use a first starting address of a data segment, which is a 0x1001. Okay, so from there, the starting location, then we can calculate the distance based on the offset. Offset here is considered in, we calculate it in bytes. Okay, you need to consider it as a byte because um to go to the next word, then we need to multiply by 4. But if you want to go to the next half word, then it should be multiplied by 2. And then if it's a 1 byte or load byte, then it should be in 1 byte. Okay. For example, load word. So load word means that it must be in a 4 bytes multiplication. So here the immediate is 16, okay, as the offset, and then the content is inside T1 as the base address. So let's say there's an address 1001.0.0.0, and then we add it with 16. This 16 is a decimal. So in this case, it's a 10 hexadecimal, right? So 10 plus 1001.0.0.0, you will get 1001.0010. So that's the effective address. So this is what we call as a base addressing or displacement addressing. Okay, because we need a base address with an offset to go to that effective address. Okay, thank you.